Alright guys, in Unit 9 we are moving on to stuff which should be pretty much completely new for you. In Unit 9, Part 1, we were talking about relations and functions. And then as we move on, we'll look at graphing, linear equations, and then also look at using intersection graphs. So in Part 1, we're just talking about relations and functions, so a really quick intro basically. The first thing to talk about is what is a relation. If you look at these coordinate pairs that I've written down for you, this is an example of a relationship, a relation. So a relation is a pairing of numbers in one set, which we call a domain, with numbers in another set called the range. So just to remind you, the first number in an ordered pair is the x, the second number is the y. So I just said that we put them in two different sets, the domain and the range. The domain is all the x values, the range is all the y values. Now we also call the domain the inputs and the range the outputs. So if you look at the ordered pairs that we have right here, your domain would be 2, 4, 5, and 7, all of the x values. The range would be 32, 59, 65, 69, 96, all of the y values. So scrolling down, it just says to identify the domain and range. So again, remember the domain is all of our x values. So in this case, that's 0, 1, 2, 3, and 4. The range is all of the y values, 2, 4, 6, 8, and 10. Now I know that sounds really basic, and it is, but you have to make sure you understand that before we can move on to anything else. So for number 2, we're doing the same thing. We'll want to identify the domain and range, but instead of having ordered pairs, they have a table here. But if you look at it, there's still ordered pairs because it's still an x with a y. So our domain is 1, 4, 7, and 10. And our range in this case would be -5, -4, -3, and -2. So the domain is all the x values, the range is all of the y values. So looking at the back side of the page, on the top, we're looking at the different ways that you can represent a relation. So the first way is the table, which I already gave you. And again, if it makes it easier, you can rewrite these as ordered pairs. So -2, -1, -1, 2, 0, 4, and 1, 5. Now, I might want to write these in ordered pairs because another way that we can show a relation is with a graph. And if I'm going to graph those, it's going to be easier with an ordered pair. So I'm going to graph these 4 points that I came up with. So I have -2, which is 2 to the left, and -1, which is down 1. So I went 2 to the left and down 1. -1, 2, I'm going to go left 1 and up 2. 0, 4, I'm just going to go up 1, 2, 3, 4. And 1, 5, I'm going to go to the right 1 and then up 5. And I've graphed my relation. Now I don't connect those dots or anything at this point, I'm just putting them on the graph. The next way you can look at a relation is what we call a mapping diagram. Okay, I'm going to erase these just to get them out of the way. So when you're making a mapping diagram, you're going to have one list that is all the inputs, which we know is the domain for the x values, and then you have another list which is the output, which we know is your range or your y values. So what we're going to do is we're going to put these numbers in order from least to greatest. Now for us in the table, they've already done that for us. So for the x values, it goes -2, -1, 0, and 1. For the y values, it goes -1, 2, 4, and 5. So if they weren't already in order, you would need to put them in order from least to greatest. Then we're going to put a circle around, or not a circle, I guess, an oval shape around each of these. So we've set up our mapping diagram. We have one more step. What we have to do is connect the inputs to the outputs they go with. So -2 goes with -1. -1 goes with 2. 0 goes with 4. 1 goes with 5. So this is a very basic example of a mapping diagram because they all just go straight across. Right? But just so you have this down. So we can look at a relation with a table. We can look at it with a graph or with a mapping diagram. If you look at the next part, it says identifying function. So a function is a specific type of relation. A relation is a function if and only if each input has exactly one output. So each x goes with one y. Another way to say this, and this will make more sense as we go through it, is that the x's cannot be, you can't have the same x value more than once. So let's look at how we can tell whether a relation is a function. One way that we can do that is by using a mapping diagram. So I'm going to go ahead and make a mapping diagram for this. I'll have my inputs over here, which again are my x values or my domain. And I need to put them in order from least to greatest. If you look, I have 2 2s and 2 3s. When I'm making a mapping diagram, I only write them once. So I'm just going to write 2, 3, and 4. Then on the other side, I'm going to put my outputs, which again are my y values or my range. Again, if they repeat, I only put them once. I also need to put them in order from least to greatest. From the -1, then I have 2 zeros, a 1, and a 2. And we'll go ahead and circle those, oval them, whatever you want to call it. So now I need to connect my inputs to my outputs. So if you look at my first order pair, it's 2, -1. So I need to draw a line from 2 to -1. Then I have 2, 1, so I need to draw another line. I have 3, 2. And then I have 3, 0, and then I have 4, 0. So again, my definition of a function was that a relation is a function if each input has exactly one output. If you look at 2 and at 3, they both have 2 lines coming out of them. So that means they have 2 outputs. So this is not a function. I could have also seen that it wasn't a function by just looking at the original points and seeing that I have 2 2s and 2 3s. So my x's repeat, which means it's not a function. Okay? I'll let you guys try that for number 2. Make a mapping diagram and tell whether or not it's a function. If you scroll down, it says the vertical line test. This is another way to tell if a relation is a function or not. Now, the vertical line test says that if it's a function, on no vertical line will you have 2 points. So you need to come ask me about this so I can show you a better way in your notes. But basically what we're saying is as I go along these vertical lines, I need to make sure that I never have more than 1 point. So on my first example, every vertical line only has 1 point. So this is a function. Now if you look at the second example, if you draw vertical lines, I've got 1 point, 1 point, 1 point. When I get here, I've got 2 points on the same vertical line. So that makes this not a function. I got a pretty short first lesson, but let me know if you have any questions.